Today we're going to review right triangle trigonometry. And we're going to start off with labeling our right triangle. I'm going to label the right angle C, and my other two vertices, one will be capital A, one will be capital B. And then I'm going to label the sides opposite. The side opposite of A is going to be little a. The side opposite of B is going to be little b, and the hypotenuse is going to be little c. That's just a standard notation that we use. Now, in right triangle trigonometry, we have ratios that represent the ratio of different sides for each angle, because in a right triangle, if I have two right triangles and an angle, the angles are congruent, then they can be similar in shape. They are definitely similar. So the ratios will always be in the same proportion, which is why we have standard names for our three basic trig ratios. They are the sine, the cosine, and the tangent. And from angle A, I'm going to represent those ratios. So we have the sine of A. Sin represents the sine. The sine of A is going to be relative to angle A. It's going to be opposite over hypotenuse. So the sine of A is A over C. The cosine of A is going to be, if this is A, it's going to be adjacent over hypotenuse. So that's going to be B over C. And then the tangent of A, relative to angle A, it's always opposite over adjacent. So that's A over B. Now I'm going to do the same thing for the sine of B, the cosine of B, and the tangent of B, and you'll see some relationships between the two. So relative to angle B, the side opposite is B. So the sine of B is little b over the hypotenuse, B over C. The cosine of angle B is adjacent over hypotenuse. So that's A over C. And the tangent of B is opposite over adjacent, B over A. So if you take a look at these things, the sine of A is the same value as the cosine of B, and the cosine of A is the same as the sine of B. So because we're in a right triangle, and because the opposite of one angle is the adjacent of the other, we can always say that in the same triangle, the sine of one angle is equal to the cosine of the other. And the cosine of one angle is equal to the sine of the other. Now, because we are in a right triangle, this angle is 90, which means A and B are always going to be complementary. So angle A is, actually we'll say angle B, it doesn't matter really, angle B is equal to 90 minus angle A. So we can set up another relationship here. I can write this expression all in terms of angle A, because the sine of angle A in a right triangle is equal to the cosine of its complement, 90 minus A. The cosine of angle A is equal to the sine of its complement, 90 minus A. So those are some relationships that you're going to have to know. In a right triangle, the two angles are complementary, and the sine of one is equal to the cosine of the other. So now we're going to practice some basic calculations. You will need a calculator to do this, a scientific calculator with your trig functions on there. And here I have my standard right triangle. I have two side lengths. One side has a length of 4, one side has a length of 3, and we don't have the length of the hypotenuse because it's not necessary. What we want to do is find the measure of angle A. So that's this angle here. As long as I have two sides, I can use basic trig to find that angle measure. So that's what I'm going to do. And if I look at the two sides that I have, relative to this angle, I have adjacent and I have opposite. So if you think of your trig functions, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. When I have opposite and adjacent, I know I'm going to use the tangent function. So the tangent of angle A, we write our function and we set up our ratio. That's going to be relative to angle A, opposite over adjacent. Opposite over adjacent. So that's going to be 3 over 4. Now here's what I have to do. I have to undo the tangent function. So on your calculator, if you look above tangent, you will see the inverse tangent. So to solve for angle A, I'm going to enter this in the calculator, second tangent, which is the inverse tangent. So it's the inverse tangent of 3 over 4. You also need to make sure you're in degree mode. We've talked about radians, and you'll see in your calculator that there actually is a radian mode, but we're not going to use that this year. We're going to be in degree mode. And rounding to the nearest degree, I get an answer of A is 37 degrees. So that shows you how you can find an angle measure. Now, depending on what you're given, let's say you were given the hypotenuse and the adjacent side. That determines what trig function you would use. If you were given hypotenuse and adjacent, you would choose the cosine function to find angle A. If you were given hypotenuse and opposite, you would choose the sine function. So it all depends on what you are given. For the next example, we want to find the value of x. So x is on the hypotenuse here. I'm given an angle of 40 degrees, and relative to that angle, I'm given the opposite side. So again, we have to remember our trig function. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you take a look. If I'm given opposite and I want hypotenuse, I'm going to use the sine function because that's the one that is defined by opposite over hypotenuse. So to do this, we set up our equation. This time I have the degree measure, so it's the sine of 40 degrees. That's equal to opposite over hypotenuse. Now you're going to enter this in your calculator in degree mode, and you're going to convert that to a 4-digit decimal. When you do that, you end up with 0.6428. I'm going to put that over 1, and that's equal to 5 over x. Now you cross multiply. 0.6428 times x is equal to 5. And then dividing, you end up with x is approximately equal to 7.8. So that's how you solve for a side when you are given an angle. And again, it all depends on what you are given, if you are and what you are trying to find. In this case, I was given opposite. I'm trying to find hypotenuse, so I have to use the sine function. If I were given adjacent and I want to find hypotenuse, I have to use the cosine. If I were given hypotenuse and I wanted to find adjacent, you would still use the cosine. So it all depends on what you are given.